This is video 2 of looking at the A-16 notes, which is solving exponential equations. So in problem number 3, we notice that we have 3 times e to the x over 2 equals 21. And for this one, we've got this 3 as a multiplier out in front. So that falls into this category of, first we want to isolate the exponential expression. So we're going to completely divide both sides by 3. So we end up with e to the x divided by 2 is equal to 7. And then we're trying to solve for the x, which is up there in the exponent. So we're going to have to use logarithms because we can't get these to be the same base, at least not on the top of our heads. So we're going to take the log of both sides. And since this problem has an e as a base, I would suggest, if it contains an e, take the natural log of both sides. So that means that this is going to become the natural log of e to the x over 2 is equal to the natural log of 7. And what you need to note is that this side on the left simplifies to x over 2, right? Because these are inverses of each other. This is really log base e of e to the x over 2. So it's, again, it's sort of like these cancel, and we're just left with this. And then that's going to equal to the natural log of 7. And then we want to multiply both sides by 2, so x is equal to 2. I would write the 2 in front times the natural log of 7. Notice you cannot multiply the 2 times the 7. That's the wrong order of operations. So this is our exact answer. For this one, number 4, this one again, we can't change both of those to the same base, so we're just going to have to take the logarithm of both sides. And because there's no base of 10 or e, it doesn't really matter which one you do. And so I'm going to just use ln. Like I said, that's what I usually use because that's what we use in calculus. All right, so we end up with this. So now the next step, so we've done this, we've taken the log of both sides. The next step is to simplify with properties of logs. And so the property of logs that we're going to use is that when you have the log of a power, which is what we have here, you can bring that exponent in front. So this becomes the quantity. Make sure that you have it in parentheses, times ln of 5. Is equal to ln of 50. Now we need to solve for x, but it's embedded inside these parentheses. So one way that you could do it is you could distribute the ln to both of those terms and then solve for x. Or another way you can do it is you can just say, well, I'm going to get rid of this ln 5 first. Erase this because it is not negative. And then divide this side by ln 5. So now I have 1 minus 2x is equal to ln 50 divided by ln 5. Then the next step would be to subtract 1 from both sides. I'm going to subtract 1 from here and 1 from here. So I end up with negative 2x is equal to the natural log of 50 divided by the natural log of 5 minus 1. And then at this point, and I think we've seen this before in some equations, you could say, okay, I'm going to divide by x, so I'm going to divide by negative 2. But that makes this pretty messy over here with a fraction on the top, and then you're dividing it, turning it into another fraction. So what you might want to do here is, instead of dividing by the negative 2, how about if we multiply by negative 1/2? So now on this side, we just get x is equal to, and then you have to be really careful here, it's negative 1/2 times the quantity. So when I multiply this times this, I'm going to get negative natural log of 50 divided by 2 natural log of 5, and then negative times negative is going to give me plus 1/2. And that should be the correct answer for that one.